A mate of mine sent me this question via an email, which is a question from the Advanced Extension Award from 2004. Now, the Advanced Extension Award is essentially a challenging one-off paper that gets published every year that's meant to just be hard A-level maths. For people who, are kind of good at A-level maths and find it fine and want an extra challenge, you can take this paper, and it just has a bunch of questions in it that are just meant to be A-level maths, but all quite difficult rather than the free questions you get at the start of A-level often. So okay, that's what this is, and the reason this is of note is because the mark scheme, the person who sent this to me, noticed that the mark scheme for A part 1 had 6 methods to find this radius here. So the challenge was set, right? And the challenge is set to all of you guys as well now. Can you find, and could I find, 6 different ways to find the radius of this circle based on the information that they've given me? Could I even find more than that? Could I find a way that the mark scheme hasn't got? And you should also do this, right? So have a go at this if you want to. I would highly recommend it. It is really fun. Just try and find a bunch of ways to find the radius of this. If you can only just find one, that's also great, because like I said, this is a hard paper, right? You're even getting full marks on it would be really hard. So doing a question halfway through that has, in lots of different ways is going to be a challenge, right? So even if you can just do it in one way, that would be great. But anyway, let's get into it. Let's see what I did. So I thought I would just do normal things in the first method. So I drew all the information down on the page. So these are radiuses. Tangents meet radiuses at 90, so that's there. This distance here is 4. If I draw a line in here, I make 2 triangles that are congruent, because this length is both r and this length is shared, and they both have right angles, so by RSH or RHS or whatever that congruency law is called, these 2 triangles are the same, which means this length here is 4, identical to this length, which is also 4. Now that's and this central point here is at r, 4, because this is horizontally across, because that's vertically up. Now this line here has equation y equals 3/4 x, so the gradient is 3/4, which means the gradient of this perpendicular line here is minus 4/3. And so what can I do from here? Well, I figured if I could get this point here, I'd be golden. Like if I just knew the coordinates of this point, then I could just use y minus y1 equals mx minus x1 with this gradient here, and that will give me the equation of this line, which I could then use to find r, because I'm just looking for when y is 4. So okay, that's all my plan. How do I find this point? Well, there's a few ways of doing it, and I guess when you talk about what does it mean to be a different method, there's lots of different sub-methods that really come from the same thing. So while there's a bunch of ways to do this, what I said was I called this theta, and now this gradient is 3/4. Gradient is rise over run, right? So this rises for 3 every time it runs across 4, no matter what proportion those are in. So like 9 and 12, or 1.5 and 2, like the proportion is always 3 to 4. And what else is this length divided by this length? Well, that's tan theta, right? Tan theta is opposite over adjacent. So tan theta is 3/4, and it's quite a nice little fact that tan theta is just the gradient of a line, if theta is the angle there from horizontal. So that's quite cool. Tan theta is 3/4. And what that means is I can set up a little triangle here that has hypotenuse 4, and I can call this length 3a and this length 4a. The reason I can do that is because, just like I just said, the gradient is this over this, but this over this is 3/4. Or, of course, tan theta is this over this, but this over this is just 3/4. And now I can try and find a, because I have got this locked in as 4, haven't I, from the congruency thing. 3a squared plus 4a squared is 4 squared. That's 9, that's 16, so they make 25. Divide by 25 and square root. You get a as 4/5, which means this length is 3 times 4/5, which is 12/5. And remember, that's this length here, which is the y coordinate of that point. And this length here is 4 times 4/5, which is 16/5, and that's the x coordinate of that point. So I've got the coordinates of that point now. And again, talking about sub-methods within methods, there's lots of ways to go from here, but I just did y minus y1 equals mx minus x1, filling in these 2 pieces of information to find this equation of the line, which I can't even bother to rearrange. And then when y is 4, you can just substitute in y is 4 and you can find x is 2, which means this coordinate has x coordinate 2, which means the radius is 2. And that's the radius of the circle. Like I said, there's lots of things you could do from here. You could, because you got these 2 points, you could set up that r minus this, over this, rise over run, isn't it? This over this minus this is 4/3, and you can go from there and you can just get r from that. There's lots of different things you can do, but I decided to do it that way. I'll call all of those other methods sub-methods of this first method, but I want to do something completely different now. So that's one method down. Let's do it in a second way. So my second way was to think about the equation of this circle, which is x minus r, because the center is at r, plus y minus 4 all squared, obviously both equals r squared. And now the equation of this line is y equals 3/4. So if I just look for the intersection between the circle and the line, that just means putting in 3/4 x into there. Obviously expand everything out and tidy up. Now this is a quadratic, but I know something about this quadratic, and what I know about it is that it only has one solution, because there's only one intersection between the line and the curve. So the discriminant of this quadratic is 0. So a is this, b is that, c is that. I can just square that, take away 4ac, and I should get 0. This works out quite nicely, because that just makes 100. Move it over, square root. Take away 6, 10 take away 6 is 4, minus 10 take away 6 is minus 16, and then divide by 2, and now r can't be minus 8, so r is just 2, as we found by 4. So that's 2 methods down. That method was much quicker. Let's do another method then. Let's call this theta, and I'll say again, tan theta is 3/4 for the same reason that I said it was before. And now this method is going to be quite fun. This is probably my favorite one of all of them. I called this angle alpha and this angle also alpha, because of course remember these are congruent, so these angles are the same. And now I know that theta plus alpha is pi over 2, pi over 2 being radian speak for 90. I just was doing it in radians because that's probably what Advanced Extension Award expects me to do. But also I know that tan alpha, opposite over adjacent, right, is r over 4. So I also know this, just based on that. Also this is 4 as well, isn't it? So r over 4 for the same reason. But anyway, we have this. Now I can take tan of both sides here. Now this seems like a terrible idea, because tan of pi over 2 is not defined, but I think I can work around that. So give me a second to work around that. In the formula book, which you'd be given for AEA, this formula is contained within it. So if I set A to be theta and B to be 2 alpha, I can substitute those all in and I'll get this. And now, like I said, tan pi over 2 is undefined, but what that really means is that the denominator of this fraction is 0. Like the way to make this undefined is to try and divide by 0. So I think that this thing needs to be 0. Which I can obviously rearrange. Well, I know tan theta is 3/4, remember, from here, so I can put in 3/4 there. Then I can do some rearranging. You move this over times by 4 divided by 3 to get this. Now, I want tan alpha because that gives me something, like if I knew the value of tan alpha, I could find r. I know tan 2 alpha is this, but looking at this formula again, if you set a equal to b, you get this. Like if you just replace all the b's with a's, a plus a is 2a, that makes 2 tan a, that makes 1 minus tan squared a. But I know tan 2 alpha is 4/3, so just put in 4/3 into here and replace these with tan alphas, and you get this. And I think I can just solve this for tan alpha, right? Sorry, I know tan alpha now from over here, so I substitute that tan alpha into here to get this. Tan squared is r squared over 16, and 2 lots of this is just 2r over 4. And when you do a bunch of cancelling, like that goes to a half, this becomes 16 over 16 minus this, which becomes that. These two multiply together when you got a kind of a quadruple fraction like this. These two go together, and those two go together, so it becomes 16r over 2 lots of this line. And then of course I can cross multiply. I think I left some more space. I did some cancelling actually as well. But then I finally cross multiplied, rearranged, got a quadratic which I could solve. And I hope this is all correct. We get that same r is minus 8 figure we did before, which is quite interesting. We'll ignore it anyway, and we get the radius as 2. But it's interesting that the same rogue solution came up. So somehow there is really, if you made the radius of this circle minus 8, this would actually definitely work. Don't know how to imagine that, but it would definitely work. We've got it twice now. This isn't in the formula booklet. So you'd have had to have known this off the top of your head, but the distance between a line, if given like this, which ours is actually given in, and a point here, so distance between this line and this point is what I'm going for, is given by this equation here, but I know the distance between the line and the point, it's r. So I can set r equal to all of this, where a is minus 3, x0 is r, y0 is 4, b is 4 as well, c is 0. So I think I can plug in all that information. This obviously makes 5, which you can multiply over to there. This makes this. Now there's this modulus here. I don't know whether minus 3r plus 16 is positive or negative. So what you have to do is you have to say, well, let's assume that it's positive. In that case, the mod doesn't do anything, and you get this. And then we can solve that. And then we assume that this thing is negative, and if this thing was negative, the mod would times the whole thing by minus 1. And we'd swap the signs and we get this. Let's solve both of these. The first one solves to r is 2, the second one solves that same r is minus 8 that we saw before. We ignore it and we get r is 2. That's quite a nice way of doing it, the quickest so far I think. I think that's 4 ways of doing it, is it? I've got one more then, or have I? How many words was I supposed to have? Anyway, we've got this here, Let's focus on this line. That has gradient, well, this length here is 4, isn't it? Because that's what that means. And this is r. So this gradient is 4 over r. So that's what I'll say first. That's kind of interesting. If I call this angle theta, that's between this line and this one. There's a little formula you can use, again, that the formula book doesn't give. But the angle between two lines is given by tan theta, where theta is the angle between two lines. Is this in terms of m's being the two gradients? But I know that tan theta, theta being this, is equal to like 3/4 minus 4 over r over 1 plus 3/4 times 4 over r. But think about tan theta here. Tan theta is also opposite over adjacent. It's also r over 4. So I can replace that with an r over 4. I can put in all these m's into here, and I end up with this down here. Now, okay, let's deal with this then. So let's put these fractions together. I'll be quite lazy about this, so putting those together and then multiplying these, putting these together as well. Again, this thing will cancel with this thing, so it's just this over this, which is cool. And now we get to this situation again where we don't know whether the inside of this is positive or negative. So first we just say, let's just let it be positive and solve this. And second, we just let it be negative, where we swap these first two terms around, we get that. And we solve both of these two cases. So here we can just cancel all the 4's down the bottom here. Then we can cross multiply. This is the same quadratic that we saw earlier when you take away, when you add in 3r and then take away 16. I believe it's exactly the same. Yeah, it is, because it's plus 6 minus 16. So you're going to get r as 2 from there. And then here, this one doesn't work, because when you do it, you get to here, then you cross multiply. These 3r cancels with this to get r squared equals minus 16, but that doesn't have any real solutions. So you get r as 2 as your only solution. R is minus 8 also comes from that, but I don't care. So r is 2. And yeah, I gave it away a couple of seconds ago, I think, but those are my 5 solutions. And I said 5. I couldn't find another one. I had 5 of them. The marks email was promised had 6, but I only found 5. So I was annoyed at myself then. But then actually, what that resulted in was the most fun part of this exercise, which is I went to the mark scheme to look at the 2 solutions that I'd missed. And actually, sorry, the 1 solution that I missed, but actually I'd missed 2, because the mark scheme didn't have this solution here. So I found one they didn't have, but then missed 2 that they did. But the most fun thing about this was that the mark scheme gives absolutely terrible, vague methods here, which it's actually really fun to try and understand what it is that they're doing. I thought when I went to the mark scheme that I would just, that they would all be detailed for me and I'd just be able to follow it. I'd be like, oh no, I missed that. But this is method beta, so this is the second method they're giving you. And try now, pause the video, try and figure out what this is telling you to do. Like, what are they actually doing here to find r is 2? So it took me a little while to figure out. I mean, n they haven't defined, so there's no n in the picture, so I don't know what that's talking about. I don't know what it means to have a length here like this or an arrow here like this. I assumed it meant length of something. But Cn is 4 is the big giveaway. So what distance from here to somewhere is 4? Well, the y-coordinate is 4, so I think n must be directly down, and I think that distance is 4 there. So I think this must be n here. Now, theta, I've just guessed is here. Just because that seems like the obvious place to put it. I've put it there a couple of times, and it turns out that it works quite well if you do that. Because if I put in, so this is 4 like I said, if you put in a little length here, now by alternate angles, this here is theta, like just said angles here, so that's theta, which means this is 90 minus theta, because there's a 90 there, which means from this triangle here, because there's another 90 here, that up there is also theta. And this is what gave it away, I think, because they're adding things up. Cn is 4, right? So they're adding 2 things up to make 4. And I think I can add up this thing and this thing, and I'd make 4. And this thing here, look, is just defined to be r cos theta, right? Because it's r. This is the adjacent side, so cos theta is adjacent over r times by r, and you get this is r cos theta. Now, what about this length here? Well, actually what I can do is I can say, well, that length there is the same as this length here. And this length here, because this distance is 4, this is the opposite side of this right-angled triangle, so this is 4 sine theta. Right? So go through that again. This length here is 4, so we've seen that a couple of times now. So this length is 4 sine theta, which means this length is 4 sine theta, because it's opposite the angle. You do a lot of that in mechanics, don't you, when you label like mg cos theta, mg sine theta and stuff, if you've been doing A-level mechanics. Anyway, so we have now that r cos theta plus 4 sine theta is equal to this whole length of 4. And now we already saw before that tan theta is 3/4. You can draw a little right angled triangle. 3 squared plus 4 squared is 5 squared. And you can say sine theta is 3/5 and cos theta is 4/5. And you can substitute those values into there, and you can solve this obviously, and you get r is 2. Worth noting that throughout all this, we obviously don't have calculators. Otherwise, just finding this angle, by doing tan inverse of 3/4 would be viable, but it's not. But anyway, that's the method that I missed that they had. Now, there is another method that I missed that they had that is even more fun, because good luck figuring this out. So here's what they give you. This is their entire method to get r is 2. Please do pause the video and try and figure out what they're doing for method. Is that a phi? I can't even remember. What are they doing? How have they got this? Okay, so what have they done? So theta, I'm assuming, because this is another solution from the same solution set, that theta must be the same theta they labeled before. Otherwise, they might have called it something else. Also, I know that because it says equals 3/4. So sine theta is 3/4, and we just worked out, didn't we, in the previous one that we did, that sine theta is 3/4 here. So we have that. So this is good. So where does this come from? Like, I can see that the solution here is they're just going to say sine theta is this, sine theta is this, set these two things equal to each other, and you're going to get r is 2. I know that. But where does this come from here? And this took a good few minutes of just staring at to work out. But what they've done, and this is genius, think about where else you can transplant theta to make something else. Now, we already saw that we can make a triangle in here to get a theta being here. But what if, and the other hint here, I guess, is you've got to use this line, right? Because you haven't, well, I guess you have used this line to get sine theta as 3/5, but use this line. That's the hint I'll give you. And you've also got to draw a right angled triangle. Otherwise, opposite over adjacent isn't going to, opposite over hypotenuse, because it's sine, isn't going to work. Draw a line all the way across like this. Horizontal, from this center all the way out to intersect with this line here, because now this angle is theta because of alternate angles, and now sine theta is going to be opposite, which is r, so that's good, over hypotenuse, which is here because this is the right angle. And I think I can work out this length because remember that the y coordinate of this center is 4, so the y coordinate of this point here is 4, so I just put y is 4 into this equation to find the x coordinate, which is 16/3. So this coordinate is 16/3, and then that means that this length is 16/3 minus r. Boom, got it. So sine theta is this over this, which is also equal to 3/5 based on our previous working. So this over this is equal to 3/5, and then of course we just solve that and we get r is 2. Really fun. I was surprised how this should almost be, I don't know how to make this work, but I would like to find more terrible mark schemes that I can, for questions that I just want to try and find out what it is that or figure out what it is they were doing. I just thought that was so much fun, and I've never really done it before because usually mark schemes are better than that. But I don't know how you would do that because that requires someone to deliberately write a vague mark scheme for you just to have fun with it. But anyway, that was super fun. Thank you so much for sending that. That was great.